Okay, so I guess the streaming is stuck, or I don't know what is going on. So I'll just start it anyways. Hey everyone, this is WebDev Sumos, and today we are going to solve um, questions from two pointer list. So that I'll first solve a easy one, and then I'll try to solve a medium question. So yeah, let's get started with this. Minimum difference between highest and lowest of scores. You're given a zero indexed integer array nums where nums of I represents the score of the ith student. Mhm. You are also given an integer k. Pick the score of any k students from the array so the difference between the highest and the lowest of the k scores is minimized. Return the minimum possible difference. Okay, I did not understand the question quite properly, so I'll go over it again. You're given a zero indexed integer array nums, zero indexed array nums, where nums of I represents the score of the ith student. Got it? You are also given an integer k. Mhm. Pick the score of any k students from the array so that the difference between the highest and the lowest of the scores is minimized of the k scores is minimized. The return the minimum possible difference. There's one way to pick score of one student, 90. The difference between the highest and lowest score is 90 minus 90. The minimum possible difference is 0. There are 6 ways to pick in the other example that I'm looking at. The example shows 9417 k is equal to 2. There are 6 ways to pick score of two students. Namely, the difference between the highest and lowest score is 9 minus 4. The difference between the highest and the lowest score is 9 minus 7 equals to 2. Got it. So I'm just wondering if what will be the value of it will be always a positive number from 0 to 10 raised to 5. Got it. I'm just wondering, so the scores scores that have been given to us are for the are for the ith student, so we cannot actually uh, you know sh- sort them out, so we have to keep it as is. Mm-hmm. Where do we have to start? I'm just thinking, where can I start my search from, like uh, where I'll find lowest of k scores. So it should be lower than the k scores. Minimum possible difference is 2. The difference between the highest and the lowest of the k score is minimized. K is 1. Pick the score of any k students from the array, so the difference between the highest and the lowest of the k score is minimized. So we have k is equal to 2, and there are 6 ways to pick scores of two students. Got it. Got it. k can range from, it will be equal to the nums dot length. So we what we have to do is consider all the possible case. Why is this easy? I'm not getting it. Like it's not straightforward. But is there a trick? Like this question falls under two pointer. So even if I have a two pointer, I have to check for the k differences, right? Whatever the uh, k is equal to 3 is there, so I have to consider that. How will I do that? How will I do that? K is equal to 2 is given, and k can, if in case if this k was equal to 3, pick the score of any k students from the array so that the difference between the highest and the lowest of the k scores is minimized. Okay. So is it just asking for the minimum score between any two guys, or it's I'm really stuck here. Like I'm 7 minutes into this question, and this is taking me nowhere. So there are 6 ways to pick scores of two students. Like k is equal to 2. So I'll ask for a hint for the difference between the highest and the lowest element to be minimized. The k chosen score needs to be as close to each other as possible. For the difference between the highest and lowest element to be minimized, the k chosen score to be as close as to each other as possible. So is it a sliding window problem, or how is it like? So if my k is 2, then I can come here, then okay, I can increment once my k is equal to 2, I can whichever is the smallest one, I guess I have to move that. This ain't helping. Um, what if the array was sorted? But we cannot sort the array as such, right? After sorting the scores, any contiguous k scores are as close to each other as possible. Apply sliding window solution to iterate over each contiguous k scores and find the minimum of the differences of all windows. Is that so? Is that what is going on? So if I just sort this out, so after sorting it, it would be 1 4 7 9, and I apply a sliding window of k. So how will I be moving it? So until my k becomes equal to this, then I'll bring k, slow pointer closer, then I'll calculate this, then I'll move the slow pointer here. Let's why don't I just uh, what do you say, dry run through this using our trusty Miro board. Okay, so let's say let me open up the Miro board. Miro Miro. And what was that question? The question said, um, let's say we have sorted the nums that has been given to us, 9 4 1 7, and k is equal to 2. And we sort this out then, so it will look like 1 4 7 9 are two pointers, namely sorry um, this pointer and this pointer will start from here, the slow and fast pointer. As so we'll calculate the minimum. We have to, I guess, calculate the minimum, right? Minimum that we can find. So our minimum would be this guy, and it is our k. Currently the window is equal to k, so it's okay. We can calculate the minimum between these two guys, and then move our pointer here. As soon as our pointer comes to this point, let me also indicate 0 1 2 3. As soon as our pointer comes to this point, it will be not valid. The k, it's not uh, respecting the kth window, so we have to move the left pointer to the fourth position. Now it's so now we can again calculate whatever the difference is. So the initially 0 and 1 difference was 3. Then we found 3. Then 4 minus 7 is also 7 minus 4 is also 3. Then what we do is move the window here, and it's not respecting the kth, so we move this also, this guy also. So 9 minus 7 is 1, is 1. Okay, is not 1, actually it's 2. Sorry, so the answer is 2. Where is it? Yeah, the answer is 2 in this case. Let me also check if I like what other test case that I can think of. Yeah, let's do this. If k was equal to 3 in this case, then what would have happened? If k was 3, let's say it was 3, then okay, I was just wondering, like we have there will be a time where our k will be equal to 1. So Okay, yeah, when our k will be equal to 1, then we can simply start calculating the um, left and right pointer will be pointing at the same position, then we can calculate it. But yeah, if our k is equal to 2, then we cannot do that. So I'll just run this and see what the answer is expected. So answer that is expected is 5. So I'll just go over it once more. And this time our k is 3, so our slow left and right pointer are here, and we'll start moving it. K is equal to 3, so our pointer will come here, then our pointer will come here, and once the window size is k, we'll take out the difference. 7 minus 1 is 6, so 6 would be our answer. Then as soon as I shift my right pointer here, it won't respect the k, then we have to move the slow pointer to closer to it. That will result in this going here, and 9 minus 4 is 5. So I guess that will be that will be it. That would be it. But the question was like, why the question, I guess it confused, because you are given 0th index integer array nums where nums of I represent the score of ith student. You are also given an integer k. So yeah, like it doesn't really matter if it is the score of the ith student. I guess it was given to confuse us. But yeah, let's do this. We have to first sort this question, right? Nums dot sort a comma b. Let's make it a bit large. Yeah, a minus b, so it will be in ascending order. What we have to do next is yeah, we have to basically loop through it, right? I is equal to 0, or let's loop it through using while loop. While right, let's define our left and right pointer. Okay, both will be starting at 0. Right is less than, while right is less than equal to less than nums dot length. Is that okay? Yeah. And what we'll do is, we don't have to calculate as and when the nums are there. So if right minus left is equal to, so my right here was at basically 2. 2 minus 0 is 0. Okay, so I have to basically do k minus 1 here. So whenever that will be equal, I want to calculate my minimum guy. So let min is equal to number dot max, I'll call it max, safe integer. Got it? Yeah, so if it is equal to that, then what I'll do is I'll simply calculate min is equal to math dot min. Is min smaller or math dot abs. So that would be nums of right minus nums of left. Once I found this, then okay, then it's fine. And while right minus left is greater than k minus 1, then what we have to do is we have to start incrementing left plus plus until it starts respecting the kth position, and then we have to always increment this guy, and finally we can return whatever min was there. And let's run it. So output came 6. Why 6? I sorted this out in ascending order unless and until my k. Okay, so it's failing, looks like. So let's keep it 2. So the minimum value, it's returning 1 extra. Like, why is that? So k is equal to 2, and I have to see that when right minus left equal to k minus 1, then and then only we are finding out the difference between both and storing it into the min, isn't it? And whatever will be the minimum should be the answer. Yeah, that was the plan. Okay, let me see what nums of right and nums of left is am I pointing on. Why is it taking so long? So it's just 4 and 1 and I'm not going anywhere. If right minus left, left plus plus, right? Okay, I guess I might not be doing this right. So let me get it straight. I'm going till this point, k is equal to 2 here. Then as soon as I go here, this won't be a valid window. I guess all I have to do is move this guy here, move this guy here. Yeah, I guess that's what I have to do it. That's what I have to do, because my right minus left is equal to k minus 1, right plus plus. Yeah, it worked. Yep, I knew it. That was the problem, because I was incrementing right, and then so once we do this should have been respecting the what do you say, the k, and then that's when I have to again check this guy out. So yeah, I guess that should do it. If we run submit this, hopefully that. Okay, yeah, cool. So the time complexity is O of 2n for this one, but if we remove constants, then it is O of n for doing it in a sliding window problem. So it's kind of two pointers, but it is a sliding window solution. So I guess I should um, put it in the sliding window, and let's see how many times it has been asked. So looks like it's not been asked that much because there is no companies given underneath this guy. So why did LeetCode put it in his list of solutions? Anyways, it is what it is. Um, so hopefully this was the optimal solution and not the brute force one. Let's check mark it here, and we are 26 minutes into it. Okay, so what next should we solve it? Merge strings alternately, yeah. Yeah, so I'm just solving easies. Okay, I'll solve easy for now. Then starting tomorrow we can go over mediums, easy and mediums. Because I have an interview today, I won't stress out much on solving. I guess I've solved this already. Mm-hmm. What is this? You are given two strings, merge the strings by adding letters in alternating order. Starting with, okay, yeah, this is pretty easy. This can be done easily. Let's see. Okay, Amazon also likes to ask this question. That is good. Let's put it in our bucket of done questions. Um, it's Yeah, I guess I might have not created a list for two pointers. I should do pointers. I should create that list and put it there. So I guess it's a good question to be asked in interview. Like, not a good question, but it's asked a lot of times. So yeah, as you can see, Google, Microsoft, Adobe, a lot of companies ask this question. Okay, so that's why I said good question. Okay, so I guess I might have also done this merge sorted array. Have I done this already? Yeah, I've done it in Feb 16, 2022. Long time back. I've also star marked it. What the hell is wrong with my camera? Okay, we are back. You are you're given two integer arrays nums1 and nums2, sorted in non-decreasing order, and two integer m and n representing the number of elements in nums1 and nums2 respectively. You are given two integer array nums1 and nums2 sorted in non-decreasing order. Got it. And two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. Okay. The final sorted array should not be returned by the function but instead be stored inside the array nums1. I hear you. Got it. To accommodate this, nums1 has length of m plus n, got it, where the first m elements denote the element that should be merged, and the last element the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Got it. So we have been given m equal to 3, and I guess that's what represents the actual number values that that is not 0, and n is, it signifies nums2 length and also the number that we want to accommodate here. Got it. The array we are merging are 1 2 3 2 5 6. Mm-hmm. So we have to merge them, right? We have to merge them. So I'm just thinking what can be done. So should we, I'm thinking of using two pointers, 0 and 1, like to traverse nums1 and nums2. They'll both start at their initial starting index. The only concern is that how will I make the adjustments for the two for the new values in here and replace it with zeros that are there. What should we be doing? I guess what we can do is start from the end of both of them. Okay, we can start at 3 and 6, right? That's what we can do, and whatever is the greatest of these two, we can just replace the last index with that, and then move the last index here. So 3 and 6, I'll just draw it out so that it will be easier for us to picture this. Yeah, so that is a nice trick. I guess that should work. I'm just thinking if that can work, that would be great. M is equal to 3, 2 5 6, and n is equal to 3. Got it. We'll go here. Okay, my Miro board is not yet. I gotta refresh it. Let's see if it gets synced with whatever I've done on my iPad here. Looks like it is not syncing. That is the problem with this Miro board. It doesn't sync well. So I guess the values were 1 2 3 0 0 0. M was 3, and the other value nums2 was, I think I gotta look at nums2 before I do anything else. Nums2 was 256, n is equal to 3. 256 256, n is equal to 3. So we decided that we will go from here, and we'll also have a pointer that will be pointing to the last node of this. Yeah, whatever is greatest, then we will shift, and we also need one color to point at the index that we will swap the current element at. So yeah, 2 3 and 6 will be compared. It will be the greatest of those element will be kept here. So our 0th would look like 6. Okay, and whichever was greatest, we will actually move its pointer closer closer to, what do you say, this guy. So it's 0 1 2, now 0 1 2 3 4 5, and this guy will also move here, right? Now we have to compare 3 and 5. 3 and 5 will get compared. 5 is greater, so I'll make this element 5. 5 move my this pointer here at this position, and this pointer at this position. So 3 and 2, what is greatest out of these two? What is greatest out of these two? So 3 is greater, so we'll replace this guy with 3, and 2 would be here, and 2 should be swapped with this guy, right? Yeah, we have to actually swap this position with this guy. Okay, so I guess I need to be worried about how, when things are like, if this was, let's say it was not 2 and it was 1, let's say it was 1, so what would have been different? So we found 3 here, we replaced 3 here, so what should have been in this position instead of 3? So we found 3. I guess we should have moved this pointer, whatever is greatest, that is the one we are moving, right? So I guess the next valid pointer should be here, right? We were pointing it with the orange color. Let's keep that trend going on. Yeah, so the next pointer should have been pointing here. Now I will compare, and whichever was the largest one will move here. Okay, yeah, that will move, right? So basically this guy will move here, the other index. Now 2 and 1 will be compared, so 2 is greater, so 2 is swapped on this orange location. 2 will be here, and then this whole pointer will move here. Okay, and that is when our 1 and 1 will be compared with each other. Then if they are equal, less than equal to, then we have to shift. Yeah, and I guess once we are done traversing the this guy, whatever the nums2 array, that's when we have to stop doing this. That's what I feel. Interesting question. I guess I might have not come up with the solution last time I solved this, because I might have seen the solution, because in the first attempt I've solved it, so I probably might have seen a solution. I should make a practice of writing a note to the submissions that I've solved using watching a video. So the next time I come to that problem, I will know that, okay, yeah, this problem I might have not done it with myself. Okay, so we have been given the m length and n length, so we know where we can start from. So our let I is equal to 0, it will be m minus n, m minus 1, and then jth pointer for nums2, that will be also starting from n minus 1, and the kth pointer will where we'll be placing everything should start from m plus n, m plus n minus 1. Okay, so that is what we have to do. And then what we'll do next is, so I need to check till what point I have to run this loop, right? I need to be careful about that. Until what point I have to run this loop? Should I be running until k reaches 0, or should I be running until yeah, I guess I should be running this until k is less than equal to 0. So k is k is less than equal to 0, we have to run this loop, right? So now what we'll check is which one of the last pointer that we are pointing at is actually greater. So once we find the greater of both, then we'll move that pointer. So find which one is greater if nums of I is let's do it in terms of if nums of j is greater than nums of I. Then what we'll do is, even if it is greater than equal to it, what I'll do it nums of we have to swap it, right? We have to swap the larger element with k, with the kth position. So swapping nums of 1 of k, nums of, actually we don't have to actually swap anything, we have to just do nums of k equals to nums of j. Yeah, that's what we have to do, and j plus plus basically, so that j pointer will move ahead. Else if nums of I was larger, then nums of 1 of k equals to nums of j, nums of I, and I plus plus, I minus minus, sorry, both will be minus minus because we are moving backwards, to moving from back to the front. So yeah, and yeah, this is what it is. And we also have to update our k, right? So the k is moving towards the front always, k minus minus. Will that work? And we don't have to return anything per se because we have to do everything in place. So will this work? Should we try run this one more time and check before running it? Because it's a good thing, good practice to try run it every now and then before 1 2 3 0 0 0 2 5 6 n is equal to 3. I'll put 6 here, move my point. I'm just I'll just show you guys what I'm doing. I'm try running it like quickly. So my pointer is, next pointer is here, my pointer is here, so I'll make it 5, move the pointer here, next pointer is here, then 3 is greater, then my next pointer is here, and then next pointer is here, then 2 and 2 is greater, so I'll make 2 here. And the problem with, and then k would be pointing here. I guess we have to do it until I don't think so we have to do it until k is less than equal to 0. I guess we have to do it until any of them. So the length, so the question doesn't specify really which one is greater, right? M and n could be ranging from 0 to n, 0 to 200, and okay, m is greater than equal to 0 and n is greater less than equal to 200. So m plus n is always equal to 1. Like my intuition is saying that we have to run this until whatever is in nums2. So nums1 will be always be that bigger until it can accommodate everything onto its array size. So I guess because of that condition, I will say until my j reaches, until all of my j I've kept it in the proper place. I'll be moving this counter. I hope that works. Until my j is less than equal to 0, I want to proceed with this, whatever we are doing. Otherwise, I would like to stop. So let's see if that works. nums1, oh, nums2 and nums1, nums1, nums2, nums1, nums1. Okay, sorry about that. Okay. So why did it go out of bound? Did it go out of bound again? Should I be also be concerned about I is less than equal to 0? Oh, sorry, my bad. While j is greater than equal to 0, I have to do this. I was doing it other way around, sorry. So I guess it's while j is greater than equal to 0 or greater than 0. And I is greater than equal to 0. So this both came out to be right. Okay, but this guy where there was 0 and just a 1, the output was 1. Why is that? So my m was 0. Sorry guys, I'm getting a call. Oh, my Okay, my phone is not with me. It's upstairs, but it's still connected somehow. Nums one of k. Where I might be going wrong, I'm not sure. Nums two, nums k. Okay, I'm just doing now this a foolish way of trial and error. This is not working. I'll just see what my solution was from earlier. Okay, any of them could have been k minus minus. I guess any of them would end more quickly. Then what I have to do is I have to basically uh, yeah, keep on looking for it. I Okay, my bad. My idea of doing that was almost there, but not there. So I guess I might have to look at this again. Okay, cool. Not cool actually, but yeah, like I'll mark this question to be practiced again. So I'm still stumbling upon the easy questions. That is not at all good. 2 pointers, right? Okay, got it. Okay, guys, we were not able to successfully do it in time, but guess we'll keep trying and keep getting better at it. Um, I'll again solve this question so that I, after some time, not today, so that I know where I went wrong. Let's see the companies that, oh my goodness, this is the most, like, really the important question. How can I not emphasize how important is this? Like, look at the number of companies have asked this question. I must write it down somewhere under 2 pointers or somewhere. Yeah. So I'm making a list where I'm writing down all the questions which are really, really important. So this is one of them, which is an easy question. Look at the number of companies have asked this question. Just look at it. Intuit, Infosys, IBM, LinkedIn, Yandex, Shopee, Bloomberg, Atlassian, even TCS was also there. So first, merge, sorted, array. Okay, okay, guys. The this was a good session about we did it. We did 2 questions in about 1 hour. Those were easy questions, but yeah, this one was pretty tricky, and this one was a good one, but I have to